So, what day is that? One day we were talking about particle motion. All right, we came up with the conclusion that if the velocity was increasing, or if the velocity was greater than zero, we knew that the position was moving to the right. All right. We also knew that the velocity was less than zero, the particle is moving to the left and moving down. And if the particle, or if the velocity was zero, then the particle was at rest, and it was shelved. It wasn't moving. Right? We also talked about how if we're looking at the velocity graph, and the velocity goes from positive to negative, it changes direction because then the particle goes from moving right to moving left. Right? And what we got to at the end is we started looking at a graph in this one that's talking about whether or not this particle is speeding up or slowing down, and how we get it, and how we figure that out if we have a graph of velocity. Okay. So, what we want to look at here is when we say speeding up, right? So we're talking about speed, right? Not velocity at that time. So speeding up, that's essentially saying when something speeds up, the speed is increasing, right? So speeding up is the same as saying speed increases. Right? And slowing down means that the speed will decrease. Now, right now, we have a graph of the velocity. All right? And the velocity graph is not our speed graph because velocity has a negative value, but does not have a negative value. And we know that speed is what? It's the absolute value of velocity. All right? So what we want to be able to do is we want to be able to take this and get a sort of a graph of, we want to take our velocity graph and get a graph of our speed. All right? So we want to be able to figure out when is this particle speed increasing, when is this particle speed decreasing. So how can we do this? Well, like I said, we know that speed is the absolute value of velocity, right? So we can quickly turn any graph, we can quickly look at a graph and take any velocity function and turn it into a speed function or a speed graph by taking the absolute value of each part of that graph. The absolute value of the negative number turns it into a positive. So what's going to happen here is we're going to take this part right here, right, and this is going to reflect over the y-axis, over the x-axis. So that's at negative 2, and now this is at 2. And it's going to go down to right there. Right. So this new graph goes down here, and it stays constant. Keeps following this graph right here. Then this piece right here is negative. It's going to reflect over the x-axis. So this looks like at maybe 7, right? It is at negative 2 constant. So we're going to do that positive 2. Right here. So what happens is this all affects up. There, and the rest of that graph goes right there. So the blue graph is now our speed graph. Does that make sense? So all we've done now is we've taken our velocity, taken the graph of our velocity, and moved it. We've taken the absolute value of each part that is moved as a negative value has now become positive. So we now move that to our velocity graph. All right. So we said that we want to figure out when is this function, or when is this particle increasing, and when is this particle decreasing. All right. So what we want to look at is this. We have, let's just say you want to look at t equals 6. Okay. At t equals 6, is this function speed increasing or decreasing? At t equals 6. It's increasing because our speed function is moving up. We went up at t equals 6. It's increasing. Right? So the speed is going up. Alright. So let's let me ask you guys some questions. Alright. Let's do this. So t equals 6. Now, next question, let's look at t equals 4. So t equals, at t equals 4, is the speed decreasing or increasing? So the speed is decreasing. Alright. And we got that because right there, speed is decreasing. Now, that's second time. Let's look at t equals 2. Alright? Show at t equals 2 is the speed increasing or decreasing? It is increasing right here. Increasing, so the speed is going. Alright, I'm going to ask one question right now. You're typing why is the speed not and you know, pretty simple. You say exactly. Alright, well, t equals 8. That's fine, because what you're about to come up with here is one of the more important parts about velocity and speed. Oh, well, just deal with it. I want to confuse you. So, t equals 8, Shamar, is the speed decreasing or increasing? Decreasing. So, the speed is not increasing. Speed is decreasing. Alright, so finding out if the speed is increasing or decreasing is pretty simple if you have the graph, right? All you have to do, take the graph of your velocity, take out the value of all the negative parts, and you can then look to see where your speed is increasing or decreasing. But here's the issue, right? What if you're working on a problem on the AP Calc test where you're not allowed to graph the function? Alright, so now you no longer have the graph.
So we can't graph the speed function?
Well, let's just say, yeah, let's say you're given like a velocity function, right? And you don't know how, like you don't know what the graph is. It's a crazy function. But you do know how to find the first derivative, which is acceleration. Alright? So what we want to look at is what I'm about to show you now. I'll ask you guys a series of questions. Okay? We're talking about t equals 6 forever. Okay? So t equals 6. What is our velocity? Is our velocity so v6. Velocity at 6. Is the velocity at t equals 6 a positive number or a negative? It is a negative. T equals 6, and right here, our velocity is a negative number. So right here, the velocity at t equals 6 is negative. Right? So this is the next question. The acceleration function is the first derivative of the velocity function. And the first derivative tells you the slope of a function at a point. What is the slope of this function at t equals 6? Is it positive or negative? It would be negative because the slope of the tangent line right there is negative. Alright? So the acceleration is negative. Alright? So let's look at t equals 4. I'm going to ask you the same question. I want to know is the velocity at t equals 4 positive or negative, and I want to know if the acceleration at 4 is positive. So, Shamar, is the velocity at t equals 4 positive or negative? Positive. Alright. And Mark, is the acceleration at t equals 4, starting at this point, is the acceleration positive or negative? If we draw a tangent line, is that still positive or negative? Negative. Alright, because, yeah, that tangent line would be going down. Alright, so, yeah, that's going up. So, t equals 2. The velocity of at t equals 2 and the acceleration at t equals 2. Alright, so they're both positive. Good. Alright, and then one last one to look at. T equals 8. So Shamar, the velocity at t equals 8, is it positive or negative? Yeah. Alright. And is the acceleration at t equals 8 positive or negative? Positive. Alright. So all that right there. Do you guys notice anything about like when the gravity particle's speed is increasing or the particle speed is decreasing? So okay, so instead so we can sort of write less and write it down. A particle's speed is increasing when the velocity and acceleration are or have what? You said positive and positive or negative and negative, so they have the same sign. Alright? This is very important. This helps us out a lot. Alright? So yeah, so here's what I'm saying. A particle's speed is increasing when the velocity particle speed is increasing when the velocity and acceleration have the same sign. Right? Second thing we have is a particle's speed is decreasing when what? Yep. Okay. So, those are two very, very important concepts to take away from it. Right? Particle speed is increasing when the velocity and acceleration have the same sign. A particle speed is decreasing when the velocity and acceleration have different signs. That's true no matter what. No matter what function you do. Okay? We're good on that. Take that away from this page. So, let's look at a problem. So I want you guys to write down this problem so you have this example. Okay? And this is going to be a lot of what your homework is like tonight. This type of problem. Ready? So the particle moves along the line so that its position at time t greater than or equal to 0 is given by x of t equals t cubed minus 6t squared plus 9t. It asks, when is the particle at rest? So what do we need to figure out in order to figure out when the particle is at rest? Set what equals 0. Now the position, the position functions up and tells us it's at rest, it's at rest, and then it's equal to, that means that it's not moving, right? So if we're talking about not moving, we need to know which one. Which would be the velocity. So we need to figure out, okay, so we want to figure out when does the velocity function equal to 0. Well, as Michelle said, we need to find the derivative. So the derivative of x of t, so d of t is equal to, what would d of t be equal to? At what? Squared. Plus 9. Right? So 3t squared minus 12t plus 9. Now, I see that. I'm not letting you guys up using a calculator here, but what I do know is that I can factor that. Alright? So that can be factored to 3t squared minus 4t plus 3, which is equal to 3 times t minus 3 t minus 1. So all I did is take 3 out. That makes this much easier to factor. T minus 3, t minus 1. So that tells me that this velocity, that this particle is going to be at rest at t equals 3, t equals 1. Questions about that? Does that make sense? You'll do a lot of that on the homework. So now it asks, when is the particle moving to the right? Moving to the left. Okay. Do you remember what the relationship is between velocity moving to the right, left, and stuff like that? So if the particle is moving to the right, what does that tell us about the velocity? Yes. So velocity is 0. If we're moving to the left, Shamara, what does that tell us about the velocity? Good. Okay. So what I need to do is I need to figure out at what times is the velocity greater than 0 and less than 0. So I'm going to show you guys may have seen this before. I think I showed you this a little bit on Monday or Tuesday when we were working on the homework. How we can do this. Because you don't have a graph. Okay, you don't have a graph like that. So one way to do this is to make what we call a sine table. Alright? Sine table, you just make a number up. Alright? And you put your numbers where the function is equal to 0 on the number. So we're talking about velocity is greater than 0, velocity is less than 0, we're using the velocity function. Alright? So where's the velocity function equal to 0? 1, 3. 1 on the number line, 3 on the number. So I have, in this case, 3 places that I need to check the sign of my function. Alright? I need to figure out, is the velocity function positive or negative over here? Is it positive or negative over here? Is it positive or negative over here? I know right here and here, 1 and 3 is 0. Alright? So what's going to happen is it's either going to be positive or negative. 0, positive or negative. 0, positive or negative. How can we do that? Well, we're just going to take numbers on this number line, plug them into our function. Alright, I'm going to use this one. So if I take, what's the number that's to the left of this where it would be going? Negative 1. Well, let's choose something much easier. 0. Okay, 0, you can add 0 seconds. So, you take 0, and you plug 0 in. If I plug 0 in here, I'm going to get -3 and -1. So -3 times -1 is a positive number, times another positive number, that's positive. Okay. Now I'm taking number between 1 and 3, so we're going to between 1 and 3, you sure? Something that's nice and easy. 2. Alright, 2 minus 3, that's negative. 2 minus 1, that's positive, so positive, negative, positive, that's going to be what? Positive times negative is positive and negative. Okay? Take a number bigger than 3, so 4. Alright, so plug the 4 in here, you get positive and positive, so positive, 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 positive. Okay, so this particle is moving to the right when our velocity is greater than 0 or positive. So when is our velocity greater than 0? When is our velocity positive? From 0 to 1, so it's moving to the right from 0 to 1, and our particle moving to, or our particle
Well, why
moving.
is it not positive from 3?
What do you say?
Why is it not positive from 3?
There's 1 over to infinity, or do you need 1 to infinity?
Okay, why is it 0 to 1 and then 3 to infinity? Why is it negative and negative? I mean, yeah, why is it negative and
Because you can't have negative 2 seconds. So yeah, technically it's negative infinity to 1. However, when we're dealing with a particle can't travel back in time. Okay. So moving to the left, Shamar, when is the velocity less than 0? 1, 3. So moving to the left, 1. Alright. Questions about that? Alright. So, the next question says find the particle's displacement over the time interval 0 to 5. You guys remember the equation for displacement? So this is x of v, because it's x. Yeah. So we just put it over position at time v, so the final position minus the initial position. So it would be s of 5 minus s of 0. Alright, so I go up here. I plug 5 in up here. I'm going to get 5 cubed, that's 125. Alright, so that's 125 minus 5 squared is 25. 25 times 6 is going to be 150. And then plus 9 times 5 is 45. So 125 minus 150, that's going to be negative 25. Negative 25 plus 45 is going to be positive 20. Minus s is 0. If I plug 0 into this, I'm going to get 0. So it is 20. Did you get this units? No. Oh, just not be second. Displacement. Displacement would be a distance. So you can put speed if you want to use speed. I'm going to leave it at 20. So now it says find the particle's total distance traveled over 0 to 5. Okay? Here's the thing. Alright? We don't have a sort of nice little formula to figure out total distance. What we do have is sort of a procedure. Okay? And that procedure is to look at that procedure that we look at, that we use, is to look at what position the particle is at every sort of major second. Right? Now, what I do want to look at so what we need to do is we need to look at position. Alright? We have 0 to 5. So what I'm going to say is let's just take T and we have S of t. We're going to go 0, 1, 2, 3, 4, and 5. Right, this is from 0 to 5. That makes sense. Make room for 5. So what we're going to do now is we're going to plug each of these time values into the initial function that we have. Okay, so we know if we plug 0 in, we're going to get 0. We did that. Now we go up here and look at what? The position function. Which is the initial function. So now we plug 1 in. Alright, so we plug 1 in, we're going to get 1 minus 6, that's negative 5, plus 9, that's 4. And 1 to it. 2 cubed is 8. Minus 2 squared is 4. 6 is 24, so we'll subtract 24 plus 18. So 8 minus 24 is going to be negative 16, plus 18 is 2. Three's next. That's 27. That's 27. Minus 3 squared is 9. 6 is 54. 27 minus 54 is negative 27. And plus 27 is 0. That's plus 4. 4 cubed is 64. That's going to be plus 36. Minus 4 squared is 16. 16 times 6 is going to be minus 6. So 64 minus 96, let's see, 74, 84, 94, 32, so negative 32 plus 6 is 4. Okay, so now what we have to do is we need to figure out, right, 0 to 4. So 0 to 4, that is a distance of 4. 4 to 2, that is a distance of 2. 2 to 0, that is a distance of 2. 0 to 4, that's 4. From 4 to 20, that is
15.
16. So we add these. 16 plus 4 is 20. Plus 4 is 24. Plus 2 and 2 is 28. So the total distance down is 28. Right, so what you do is you go ahead and you take this information and you use like the full settings. Okay? So finding the particle's acceleration when the speed is equal to 0.5. Alright. So what do we know? Acceleration, the function for acceleration is the second derivative of 1. Yeah, so the derivative of velocity, which makes it the second derivative of position. So we know that acceleration a of t is equal to the derivative of velocity. So you guys have the velocity function there. What is the derivative of the velocity function? Tell me.
It's going to be like 16 minus 20.
Alright. 16 minus 12. We want to know what the acceleration is when t is equal to 0.5. Alright. So you plug that in, so it's going to be 6 times 1/2. That's 3. 3 minus 12 is 9. This is what we call peak percent, or actually peak percent squared. Because acceleration of time, the unit of time squared. Alright. So here's the question for us. Why don't we just learn? Is the particle speeding up or slowing down when t equals 0.5? So in order to figure this out, what is it that we need to know?
So you gotta know if that variable rate,
Yeah. Sure.
that
T equals 0.5, which is what?
is the coefficient from the supplement.
We have to know whether or not the acceleration, if we know that the acceleration is negative, so the acceleration of 0.5 is a negative. Alright, so we need to find v of 0.5, so how do you find v of 0.5? So plug it in, so, the velocity function is 3t squared minus, so it was 3 times 0.5 squared minus 12 times 0.5 plus 9. Is that right? So 0.5 squared is going to be 1/4, 3/4, minus 6 plus 9. So 3/4 minus 6 is going to be 5 1/4. And negative 5 1/4 plus 9 is going to be a positive number. So this is going to be a positive number. So since our signs are different, that tells us that this function is doing what? Right. So it's slowing down. And what you guys need to do, you didn't have to do it right now, it's all out, because when you have short answer questions on your AP test, you actually have to respond and like sort of explain. It's slowing down because A of t is, what do you say, less negative, so it's less than 0, and d of t is greater than 0. Or you could say slowing down because acceleration and velocity are different signs. Is that? Questions about